Now that you are somewhat familiar with what a parametric equation is, we are now going to do some examples. At the end of this lesson, you'll be able to graph a parametric equation, and then you'll also be able to eliminate the parameter. Right, if you'll look at these first examples as sketching a curve examples, fill in the appropriate table and sketch a graph of the ordered pairs. Next, eliminate the parameter and write as a relation between x and y. And also we'll note the orientation or the direction of the curve when we actually graph it. So what we're going to do to get these x and y values, we'll just plug -2 into the x equation and we'll plug -2 into the y equation until we get it. So when we plug -2 into this equation right here, 3 times -2 minus 1 will be -7. And I'm just going to stick with the x's for all of these first. If I plug in -1, 3 times -1 minus 1 will be -4. Plug in 0, 3 times 0 minus 1 is -1. Plug in 1, 3 times 1 is 3, minus 1 is 2. Plug in 2, 3 times 2 minus 1 is 5. All right, now we're going to do that same thing with the y. So if I plug in t equals -2 into the y equation, 2 times -2 plus 1 will be -3. Plug in -1, 2 times -1 plus 1 will be -1. And then 2 times 0 plus 1 will be 1. 2 times 1 plus 1 will be 3. And 2 times 2 plus 1 will be 5. Okay, so now what we're going to do is actually graph those. So we're going to start at -7, -3. So we'll go to the left 7, and then down 3. Okay, whoop. Then we'll go to the left 4 and down 1. And then we'll go to the left 1 and up 1. And then we'll go to the right 2 and up 3. Then we'll go to the right 5 and up 5. Okay, now notice it said to note the orientation and the direction. This is where we started, and what happened over time, I'm just going to follow the path that I just graphed them in order, so we can notice that is what is happening. And I'm going to draw some arrows to show we started here and we were headed up towards the right. So that would be a graph of what it looks like. And the second thing that we're going to be able to do is eliminate the parameter. So what I'm going to do is take one of these equations. I usually like to take the x equals equation and solve it for t. So we're going to have x equals 3t minus 1. Solve it for t. So I'll add 1. We'll get x plus 1 equals 3t. And then we'll divide everything by 3. So we'll get t equals 1/3 x plus 1/3. Okay, so once we do that, the second step, that's step 1. Step 2 is to plug t into the second equation. So now we're going to go into the second equation, plug t in. So we'll get y equals 2 times 1/3 x plus 1/3 plus 1. So if I distribute, I'll get y equals 2/3 x plus 2/3 plus 1. And if I combine like terms there, I'll get y equals 2/3 x plus 1 2/3. So that's what my equation would look like if I eliminated the parameter. And you'll notice when I do this, if you look at the graph, if I were to graph y equals 2/3 x plus 1 2/3, 1 2/3 would be my y-intercept, which notice it's hitting about right there. And then if I went up 2 and over 3, I actually end up getting that same line. So this graph actually represents this line, but it does more than that because it shows me where I start, it shows me which direction I'm heading in as I go, and it actually shows me where I am at each step in time. All right, let's take a look at example number 2. We have x equals t squared minus 4 and y equals t over 2. Again, I'll take the x values first and plug them in. If we plug -2 in here, -2 squared minus 4 is going to give me 0. If I plug 1 in, -1 squared minus 4 will give me -3. If I plug 0 in, 0 squared minus 4 will give me -4. If I plug 1 in, 1 squared minus 4 will give me -3. And then 2 squared minus 4 will give me 0. All right, now go into my y equation. If I plug in -2 divided by 2 is -1. -1 divided by 2 is -1/2. Plug in 0 divided by 2 is 0. Plug in 1 divided by 2 is 1/2, and plug in 2 divided by 2 is 1. So we're now ready to graph it. We always start at the left endpoint here, so we're going to start at 0, -1, so that's where my graph actually starts, or my object, or whatever it happens to be. And then my next point is going to be -3, -1/2, about right there. And then we have -4, 0, and then we have -3, 1/2, and then we have 0, 1. Okay, so if I'm starting to start where I was at, and now we're just going to draw my curve, so it was going this way, and I'm assuming that it would keep going. So I'm going to put an arrow, and I'm going to put a few arrows on it to show this is where I started and this was the direction I'm heading in. All right, so now if we wanted to eliminate the parameter, again, I generally like to start with the x equals 1. So step 1, x squared equals t squared minus 4. We will solve for t, so I'll add 4 to both sides. And then I will take the square root. Remember, when we square root, we do have to put plus or minus. So I'm going to get t equals plus or minus the square root of x plus 4. And then step 2 is to take that t and put it into my other equation. So I'll have y equals plus or minus the square root of x plus 4 all over 2. So that would be my equation. And if you'll notice, if we had, this is a positive and negative square root of something, the positive would actually be this first square root, and then the negative one would give me this square root. The only thing that this equation doesn't do, it actually doesn't stop right here. But again, notice it just takes a normal equation and it puts some direction to it. It shows which way an object is traveling at a certain spot in time instead of just getting an overall picture of what's going on. So hopefully now you can graph a parametric equation and eliminate the parameter.